Fine. So this is where we had concluded our last lecture, and I will start again with a little bit of repetition. That this is what we were discussing about the tasks that a control system has typically to perform. If we segregate the various tasks that a control system performs, then you will come across these three basic types. In the first type, the control system has to handle a sequence of events, and such sequence of events is mostly digital in manner. You can see here that the particular example that we had taken, this was the example of a conveyor that is continuously moving. So there is one motor that is continuously keeping the conveyor in a rotating mode. Then you have got one photo sensor and a source of some sort, maybe it is a laser or it can be an IR source. Whenever some material comes in between the source and the detector module, then there is an intermittence in the optical path. That means the optical path is disturbed. Now if suppose there is a transparent material, then the optical path is not going to be disturbed, and if there is an opaque material, then the optical path is going to get cut. So these are the two situations in front of you. Once the optical path is continuous, or other the optical path is discontinued. Now you can decide that which material you may like to take the transparent material continuously, or you may like to have the transparent material deflected to a separate path. So there is a deflector which is again controlled by some sort of electropneumatic arrangement or by some motor. So whenever that particular material will be there, either it is a transparent material or it is a opaque material, according to the program that you have made to your controller or whatever it is for now, that when that material will be coming, the deflector will be coming in the path of the conveyor belt, and that item will be deflected towards a separate channel. So this is one sort of event where you can find that there is no continuous change in any of the variable. No continuous change in any of the variable during the entire process. Let us come down to the next one, where you need to maintain a variable constant. So what we have done here, you can see that this is the description of the entire process. So this is a tank, you can see this is the source, this is a load, and there is a faucet. Okay, and this is just to show you that with respect to time the situation has to be monitored. Now you see that with respect to time we have to maintain a continuous flow. Now this is going to be very critical, because you see, when this drum is completely filled up with water or whatever it is, then for a particular opening condition of the faucet, you will have a certain amount of flow. Let it be x liter per minute. Now if the level of water comes down, then you are very sure that the same amount of flow cannot be maintained. So under that circumstances, if you want that the flow has to be maintained throughout to a constant value, then you are to continuously have a monitoring over this faucet condition. When the liquid will be coming to a very low level, you need to open the faucet to a further amount in order to keep the flow to be constant throughout. So this is one thing, one sort of task that the control panel normally that performs. And next task is when you are having a continuously happening process. Continuously happening process means again there is a clock in order to synchronize our action, and I have given you the task rather the control panel demands that with respect to time the flow should be like this. Initially there should be a constant flow, then the flow should increase to some extent, then again it should maintain some constancy, and then the flow should come down. So under that circumstances you can easily understand that the faucet has to be opened and closed accordingly, so that you can I think you need to unpin your screen. You need to unpin yourself. आपके जो गूगल के फॉर्म है ना, उसमें जाके अनपिन करो आपके स्क्रीन पे, आइदर पिन करो या फिर अनपिन करो। और दिख रहा है कि नहीं बताओ मुझे। Are you getting it? Okay, ठीक है अभी? Is it okay? So everybody is getting the screen right now? बेटा आपके पास क्या दिख रहा है इतना मुझे बताओ. गणपति बापा इज ओके फाइन. व्हाट यू कैन डू इज गणपति बापा के ऊपर एक पिन दिख रहा है आपको, पिन पिन, उसको अनपिन करो. दिख रहा है? अरे बाप रे. नाउ इट इज. बाकी सबको दिख रहा है क्या? किसी को भी नहीं दिख रहा है? ठीक है, आई विल अगेन. वाह, सब दिख रहा है सबको? ओके ओके फाइन. तो अब तक मैं जो बोल रहा था आप किसी को दिख नहीं रहा था? हे भगवान, अभी दिख रहा है? ओके, अभी ठीक है. एवरीबॉडी क्लियर? Okay, fine. I will again resume. Now you can see here. अरे बाबा किसी का स्पीकर ऑन है, म्यूट करो प्लीज. Now you can see here. Initially we had talked about a sequence of event. In the next case we have seen that how to maintain a variable constant, because the flow is continuously variable and you need to maintain the continuity of the flow. And finally we were discussing about this particular process which is continuously happening. That means that whatever this liquid amount, right, this is going to vary continuously. Whatever the output of this faucet is, that is going to vary continuously, and in order to maintain that varying flow with respect to time, you need to see that what is the flow chart that has been given to you. So you can see there that initially you need to maintain a certain amount of flow, then you need to increase the flow, you need to again maintain the continuity, and finally you need to keep your flow to a marginally lowered value. So here you can find that with respect to time you need to continuously maneuver this faucet to get this continuously happening process with accordance to this chart. So these are the three basic type of tasks that typically a control system has to perform. And now you are to see that how we can automate these things. Now the process of automation can be widespread. You can have several procedure by which you can do this, right? And in this particular coursework we will see that how a programmable logic controller or a PLC can be applied in order to perform such type of conditions. Okay, now you see we will have a very simple case study where we will see a sequence of events to be happening. This is the case of an automatic drilling machine, and let us see that what are the particular job that has to be performed when a drill operation has to be taken on this workpiece. So this is, you can see, this is a drilling machine. The drilling machine can be lowered or it can be taken upward. For time being, let us think that this is going to be a manual process, and later onwards we will try to automate this process. Okay, so what you need to do, initially your drill bit should not be rotating, that your spindle should be in stopped condition. Then you have to start lowering the drill. But before lowering the drill you must ensure that your workpiece is in position. मतलब this is the workpiece जिसमें आपको ड्रिल करना है. ये वर्कपीस जगह पे है कि नहीं ये देखना आपका सबसे बड़ा एक काम है. Because if you do not have the workpiece, then what will happen? Your drill will be getting collided with the bed and the drill might be damaged. Therefore you must ensure that workpiece is there. तो पहला स्टेप क्या हुआ, आपकी वर्कपीस यहाँ पे आना चाहिए. Next, once you have ensured that your workpiece is there in the condition, then you start lowering the drill. अभी आप ड्रिल को लोअर करना शुरू कीजिए. Now you need to ensure that this drill bit has touched the workpiece. That means the drill has reached its particular position from which you will be starting the drilling work. Now you need to know till what depth you have to perform the drilling operation. That means this is going beyond the surface, and to a certain depth you need to maintain your drilling operation. So all these things have to be you should be very careful while doing all these things, because if you have performed the drilling operation to a further distance which was not required in the workpiece, then your workpiece might get damaged. And in an industrial floor, such a damage is not allowed, because it is going to be some loss in their production cycle. So they cannot afford it. Now you see, once your drilling operation is done, you need to retract the drill, then you need to switch off the unit, and you need to wait till the next workpiece comes in position so that you are in a condition to start the drilling operation for a next cycle. So you can see that apparently this is a very simple operation. वर्कपीस आ गया, ड्रिल को नीचे करो, बटन दबाओ, ड्रिल घूम गया, थोड़ा खड्डे तक लेके चलो, फिर उसको ऊपर कर दो, लाइट ऑफ कर दो, बी हैप्पी. But actually if you fragmentize these operations, then you can find that they are at the steps, and these are the particular steps that you need to perform when the drilling operation has to be done. Now let us try to see that how can we automate this system. Okay, initially I am not going to talk anything about any of the controller or processor or any smart system. What we will try to put some basic switches. We will try to put some basic switches onto several positions in order to perform this operation automatically. So let us see how it can be done. Now you see that what actually we are doing here. There is a switch that opens, right? The switch opens. Switch opens means the contacts of the switch, they are opened when the drill reaches the surface of the workpiece. So when the drill reaches the surface of the workpiece, there has to be a switch somewhere, so that when the drill reaches the surface, that switch will be pressed. When the switch will be pressed, the contacts of the switch will get opened. Now the problem is, where have you connected the contacts of the switch? The contacts of the switch has been connected to some electro-pneumatic arrangement which is actually bringing this motor down. Now what is an electro-pneumatic arrangement? आप में से कितने लोगों को न्यूमेटिक्स ये सब्जेक्ट हो चुका है? आपके ग्रेजुएशन लेवल में न्यूमेटिक्स ये सब्जेक्ट कितने लोगों को हो चुका है? Is there anybody there? Fine. So do you have any idea of electro-pneumatic arrangement? Okay, fine. Anybody else has any idea of electro-pneumatic arrangements? ओके फाइन. ऐसे कंडीशन अगर है ना बेटा, आप लोग प्लीज ऐसा मत समझो कि आई एम ए वेरी गुस्से वाला पर्सन, बहुत सारे चीज मुझे भी नहीं पता है. हाँ, तो दिस टीचिंग टू मी इज ऑलवेज अ कोलैबोरेटिव प्रोसेस. तो जब तक आप बताओगे नहीं कि सर ये जो आपने एक टर्मिनोलॉजी यूज किया इलेक्ट्रोन्यूमेटिक, ये हमको पता नहीं है, तो मुझे समझ में नहीं आएगा, है कि नहीं? And I am a very common man like you, so you need not to get afraid or you need not to get dreaded. Just ask me कि सर ये नहीं हुआ है, आप लोग मुझे बताओ. So can I go for discussion on in electropneumatics? मैं जा सकता हूँ? Okay. You see that आप लोगों को मैं एक पिस्टन ड्रॉ करता हूँ, एक सिलेंडर. Can you think of such a structure? This is a three-dimensional structure. Okay, this is going to be a three-dimensional structure. Okay, now you see that this is a three-dimensional structure. It is a cylindrical structure and it is a barrel. Actually it is a cylinder barrel. There is a piston, and here you have the piston rod. Am I clear? Now you see, here is a passage for air to enter into the system. Here there is another passage through which air can enter or exit the system. There is no binding. Air can exit through this or enter. Air can enter through this or exit through this, or air can enter through this or exit through this. There is no binding that this is an inlet passage, this is an outlet passage, like that. Now suppose we are entering air through this and we are allowing the air to exit through this channel, then this piston will make a forward motion. Am I clear? Okay, now if I do the opposite thing, that if I allow air to enter through this port and I allow the air to exit through this port, then the piston will be making a reverse motion. Is it clear? Okay, fine. Now this is called a pneumatic cylinder. Why pneumatic? Because air pressure is applied for the motion of this cylinder. Okay, now you see that there are certain kinds of valves. These valves are called direction control valve or DCV. What is the purpose of a direction control valve? The purpose of the direction control valve is, suppose where from we will get the air? We will get the air from an air compressor. This is your air compressor and you are allowing the air from the air compressor to get into this valve. Now if you control this valve in a particular manner, then on first cycle air will be entering from the compressor to this chamber and the piston will go forward, and while you move the condition of this valve, then this particular channel will be getting connected to this compressor. So under first cycle, compressor will be pressing the piston so that it goes in an extension manner, and in other cycle the air will be allowed to enter through this cavity so that the piston will be making a retracting motion. So in this way, by changing the condition of a DCV, that is direction control valve, this piston will be moving either in forward motion or in reverse motion. So such to and fro motion of a cylinder, if it is required, then you need such type of valve which is called as DCV. This is DCV. Why it is called DCV? Because this is direction control valve, so that the direction of the piston can be controlled. Therefore this is called as DCV. Now you may ask where from the electro-pneumatic terminology comes. You can see pneumatic means the cylinder is a pneumatic cylinder because the motion of the cylinder is being controlled by air pressure. So therefore it is a pneumatic assembly. Now comes the DCV. The DCV has to be moved. You know, the DCV has actually 3 chambers inside it. If it is in condition 0, the central condition is called as 0. If it is in condition 0, the cylinder will be maintained at its initial condition. If it is in condition 1, the cylinder will be going forward, and if it is in condition 2, the cylinder will be making a backward motion, or vice versa. That depends on the connection that you have made. Okay, so under such circumstances, you can understand very well that in order to make the cylinder go forward and move backward, you need to change the condition of this DCV like this. You need to change it from condition 1 to condition 2 in order to have continuous motion of this cylinder. And under such circumstances, when the changing of the condition of the DCV, ये DCV को एक बार इधर से इधर लेना, इधर से इधर लेना, इस काम के लिए आपको इस्तेमाल करनी पड़ती है एक सोलेनॉइड वाल्व. मतलब आप कर सकते हैं, आप इसको एक हैंडल से भी इधर उधर कर सकते हैं, छोटा प्लंजर से भी इधर उधर कर सकते हैं, और यू कैन यूज a solenoid valve. When you are using a solenoid valve, then when you energize the valve electrically, it will be moving in this direction or that direction. For that you are giving an electrical signal. So now you are applying an electrical signal in order to control the motion of this cylinder. Therefore this is called an electro-pneumatic arrangement. Now what you are going to do actually, you are going to connect your cylinder here. The piston rod will be connected to the body of the I should say motor assembly of the drill machine, and when this cylinder will be coming down, the drill machine will be coming down, and when this cylinder will be going up, this drill machine will be going up. And the DCV, that is the direction control valve, which is actually controlling this pneumatic assembly, is controlled through this switch. Therefore this is called an electro-pneumatic assembly. Am I clear? हाँ मैंने 11 बजे का टाइम दिया ना. नाउ आई कैन नॉट हेल्प हिम. इट्स 11:29. आई कैन नॉट डिस्टर्ब माई सेल्फ. ये चीज सबको समझ में आया? नहीं नहीं ओके तुम बोलने से क्या होगा? यू आर स्टूडेंट ऑफ बीवॉक. आई वांट टू नो अबाउट अदर्स. बच्चों को समझ में आया? बाकी बच्चों अच्छा, मैं थोड़ा कैमरे में आता हूं. आप लोगों को मैं दिख रहा हूं क्या अभी? ओके फाइन फाइन फाइन. सो नाउ व्हाट आई विल ट्राई टू डू. रुको. आई थिंक आई एम बेटर विजिबल राइट नाउ ना. मैंने सारे लाइट्स ऑन किए. ये जो आपके सामने दिख रहा है, दिस इज अ न्यूमेटिक सिलेंडर. आर यू गेटिंग इट? ओके फाइन. अभी आप देखिए, ये जो न्यूमेटिक सिलेंडर है ना, इसके दो पोर्ट्स रहते हैं. दीज आर द टू पोर्ट्स. यू कैन सी दिस इज पोर्ट 1 and this is port 2. Now what happens, that this is the piston rod rather. You can see that piston rod is coming out, or you can see the piston rod is going in. What am I supposed to do? If I allow the air from this particular port and I allow the air to come out of this particular port, then the piston will make a forward motion. This is what is called the extension motion of the cylinder. And now if I do the opposite thing, that I am allowing the air from this port and allow the air to go out from this port, you will see that the piston will go back. This is the reverse or retraction action of the cylinder. So I can do this manually. You can see I am to press. बांसुरी बजाने की तरह मैं इसके अंदर एयर को ठूसने की कोशिश कर रहा हूं. You just go get into it. Can you see the piston is going out? I am to give a lot of pressure. That's why I am not doing it till ठीक है. Now I am going for the opposite process. You can see the piston is coming back. So now you can easily understand that a human being cannot do this. For this, what you need to do, you need to apply air compression. Through an air compressor, you are applying a great deal of pressure, by which this piston can go forward and come backward very easily. Now, in order to control this motion, you need to apply certain sort of valve. This forward motion and this reverse motion, you have to apply a certain sort of valve, and that valve is called direction control valve. And when the direction control valve is actuated by some electrical manner, then we call that an electro-pneumatic system. Am I clear now? Okay, thank you. Okay, Mr. Anurag, you don't speak because you have gone through this course. I would like to ask somebody other, Mr. Hashib, you have got it, na? Mr. Anirudh, are you there? Okay, fine, fine. Mr. Nakhate? Okay, fine, fine, fine. That's better. And who else are there? Rest of the things, there are several of my students, so I think Meenakshi, beta आपको समझा है? Okay, thank you, thank you. Then I will go back to my presentation again. Okay. So now this slide is again visible to you, okay? Okay. Now you see that what is happening here, that when this drill has touched the workpiece or reaches the surface of the workpiece, the switch contacts opened. The switch contacts opened so that the particular piston that was pushing this motor assembly to the workpiece will stop. Now again the drilling operation will start, and again you have to lower that electro-pneumatic arrangement so that it slowly pushes the drill bit inside the workpiece. Now when the drill reaches the required depth in the workpiece, the switch contact will again open so that the motor stops rotating. Now these two switch contacts should work later. Initially there should be another switch contact which should be closed when the workpiece is in position. So when the workpiece is in position, there should be one switch contact, it should be closed. When that switch contact is closed, then these switches will come to understand that the workpiece is here and you need to lower the motor assembly. So now you see that in order to perform this, you need several switches. Now if you do not want to apply the switches over there, then you need to have several sensors. From the sensors, signal to be given to some sort of relay arrangement so that the relay can be simultaneously or concurrently, they can be in contact in NO condition or in NC condition, so that the drill can be lowered, the drill can be started with action, and the drill can be further lowered through the entire work, and then you need to raise the entire assembly, you need to put it off, you need to take out the workpiece. So this is the entire thing that you need to understand that you have to do. अब यहाँ पे देखिए मैंने कुछ कलर बटन्स यहाँ पे दिए हुए. These are just to collaborate the actions. These are just to collaborate the actions. अब आप देखोगे सबसे पहले ये ब्लू होता है, ये ब्लू वाला जो है, this is the first one. You can see the first one में क्या क्या है. The switch contacts close when the workpiece is in position. This I have shown with a blue label. This blue label is again here. When this blue label is activated, you can see it starts lowering the drill when the workpiece is in position. तो ये ड्रिल नीचे आना शुरू होता है. देखिए यहाँ पे नीचे आना शुरू हो गया and this red shows that यहाँ पे आ जाता है. अब ये यहाँ पे भी ये जरूरी क्यों है? Because the switch contacts has to be made when this is going to be lowered. तो यहाँ पे ये लाल और ये लाल मैं दिखाने की कोशिश किया हूँ. This is just an effort to collaborate it. अब मैं ये करूँगा, ये आप लोगों की एक असाइनमेंट की तरह मैं देता हूँ कि आप ये जानने की कोशिश कीजिए कि कौन सा स्विच कब आपको ओपन करनी पड़ेगी या क्लोज करनी पड़ेगी, so that this entire operation can be automated. These are given to you as hints. This is the start of the drilling operation. This is the end of the drilling operation, and this shows the retraction of the drill. Okay, so this is the entire thing that a controller has to do. अभी आप लोग सोचिए कि पहले ज़माने में कंट्रोलर नहीं था, ना तो माइक्रो कंट्रोलर था, ना ये पीएलसी था, ये सब कुछ भी नहीं था, तो क्या ऑटोमेशन नहीं होता था? ऑटोमेशन तभी भी होता था. ऑटोमेशन होने की तरीका क्या था? दे वेर मोस्टली रिले कंट्रोल्ड. They were mostly relay controlled और hardwired systems. यहाँ पे hardware ये बात इसलिए इस्तेमाल की जाती है because wiring, hard wiring यहाँ पे रहती थी, physical wiring रहता था. तो अभी आप बोलोगे सर कंट्रोलर में क्या कोई वायरिंग ही नहीं रहता है? ऐसा बिल्कुल नहीं, कंट्रोलर में वायरिंग बेशक रहता है, but you need to be ensured with one point that the wirings are much less in number, and in order to make some changes in the process you need not to rewire the system. What you need to do, you need to just change some of the programming commands and definitely you will be in condition to achieve that particular process. Now you can see this is a relay. I am 100% sure that most of you are very much familiar with the structure and operation of a relay. Still I am just getting a basic idea about that. You can see this is a hinge, and through this hinge a contact assembly is pivoted. On one side of that contact assembly there is a spring, and this becomes, you can see this becomes very simply a class 1 lever. Now what happens that the spring, this spring, what you can see here, just a minute, I will take the pointer. This spring tries to keep this lever assembly or this bar in such a manner that it is connected to this upper terminal. There are two terminals, you can see this is terminal 1, this is terminal 2. These two terminals are fixed terminals, and this particular terminal which can move actually, it is called the common terminal. So whenever you purchase a relay from the market, you are having three terminals outside from which you can take electrical throughputs or connections. One of the connection is called common connection, the other is normally closed connection, and the third one is normally open connection. So this thing you need to be very clear. One is normally closed and the other is normally open. What is meant by normally closed? Because normally closed and normally open, this NC/NO, these particular two terminologies will be coming thousands of times in your career when you are working as an industrial automation specialist. Okay, so you can see here that when the solenoid is not energized, when the solenoid is not energized and the spring is in its normal condition, then this common terminal is connected to this NC. That's why it is called normally closed. मतलब जब ये solenoid को आप कोई भी signal नहीं दिया, ऐसे condition को हम बोलेंगे normal condition. स्प्रिंग भी नॉर्मल है, सोलेनॉइड को भी आपने बाहर से कोई डिस्टरबेंस नहीं दिया है, नॉर्मल कंडीशन में जो टर्मिनल क्लोज्ड रहता है उसको बोला जाता है नॉर्मली क्लोज्ड टर्मिनल, और नॉर्मल कंडीशन में जो टर्मिनल ओपन रहता है उसको हम बोलते हैं नॉर्मली ओपन टर्मिनल. एंड नाउ यू सी, सपोज यहाँ पे आपने क्या किया, एक मे बी यू कैन थिंक दैट आई विल ड्रॉ अगेन. Suppose this is an LED, okay, this is a red LED which is connected through a resistor to ground, and this is connected to this terminal, and this particular terminal I am connecting to a 5 volt power supply. So this is going to be a 5 volt power supply, and this is the LED. आप लोग मेरी जो ये स्कीमेटिक बनाने की तरीका है इसको देख के हंसो मत, क्योंकि दिस इज द बेस्ट आई कैन डू. ओके, आई डू नॉट हैव ऐसी ब्लैक बोर्ड. नाउ हियर आई विल बी कनेक्टिंग अ ग्रीन एलईडी. सो हियर आई विल बी कनेक्टिंग अ ग्रीन एलईडी. I will be connecting a resistance here to limit the current so that the LED is not burnt by your 5 volt supply. It is again connected to ground, and here I will be having my circuit complete. Okay, now you see here that again you need to remember that this is not the completion of the circuit as, oh I see, this solenoid, you know, the solenoid will be having two wires that you need to connect to some supply. So what you can do, you can connect it to, again maybe if it is a 6 volt coil or a 5 volt coil, you can connect it to 5 volt directly, You can connect a switch here, and you can connect this to ground. So now I can say that your circuit is somewhat complete. So what you need to do, you can see that this is the normal condition. Normal condition means I have not energized the solenoid coil. Under such circumstances, you can see that how the circuit is made. The circuit, that means the current will flow from the supply to the common terminal to this normally closed and this ground. So this LED will glow. Now what I will do, I will close this switch. When I will close this switch, the solenoid will get energized and therefore it will draw the armature towards it. ये armature को ये क्या करेगा, नीचे खींच लेगा, and your spring will be in expanded condition. अब जब ये नीचे खींच जाएगा आपके armature, it will be getting disconnected with the normally closed terminal and it will be getting connected to the normally open terminal. Now this NO becomes closed and your NC becomes open. जब ये NO क्लोज हो जाएगा तो ये वाली LED बंद हो जाएगी and whatever your current is that will be flowing through this to ground. So अभी आपका green LED जल जाएगा. So by this manner what you can do, you can connect two different elements or you can make one different element to glow or to get electrically connected at one condition and electrically disconnected at other condition. So am I clear with the operation of a relay? Okay, now you see that how the relay is applied for a control circuit. This what I have shown is a very basic control circuit. Why the control circuits employ relays? You can see that suppose you want a simple control circuit to actuate a heavy motor. Now what is there in your control circuit? There can be a microcontroller or a PLC or a processor. Normally such type of devices are a bit delicate in manner and they are normally they are not able to conduct very heavy current. They cannot operate under very heavy voltage. So under such circumstances what you need to do, you need to differentiate or isolate the logic part of the circuit and power part of the circuit. So the motor which may be drawing, maybe if you have got a three-phase motor which is working at 440 volt and drawing some 9 amperes or 10 amperes of current, if you want your logic controller to directly get connected to the motor and you want the controller to turn on the motor, it is not going to be possible. Even your controller can get damaged out of that effort. So what you need to do actually, you need to take your logic part here and output of the logic can be given to this solenoid. Output of the logic can be given to this solenoid, and when the solenoid operates, you can see this common terminal. This common terminal, here you can apply a higher voltage and here you can allow a higher amount of current to pass. But you can see very easily that your logic circuit which is residing somewhere here controlling the solenoid, it is nowhere connected to the power circuit. So here you can see that this is the basic relay where this is a low voltage part that we can consider as the logic part. When we put on the switch, your solenoid will get energized, and while your solenoid is getting energized, the relay actually gets in operation and your motor do start. But still you need to remember that what is the capacity of the relay, how much current the relay is going to pass, what is the maximum value of current that you can allow for the relay, through the relay, that you need to decide, that you need to know very well before connecting the relay to the circuit. You should not be under any such consideration कि सर ने बोले हैं रिले लगा दो हायर करंट के लिए, कोई भी वैल्यू का रिले लगा दिया and your current starts passing. This is not going to happen. Okay, so under such circumstances what is going to happen, that your motor will be starting through the motor which is a heavy current element. It will be starting by the operation of this relay which is being driven by a low power circuit. So is this concept clear to you? Now remember that such type of approach was very common earlier before the advent of PLCs, controllers or some sort of processors. This is the traditional approach, and in many cases if you want to operate only one high power drive or one only high power load, then there is no point of actuating any processor for or controller for that because they are costly affairs. So under such circumstances you will definitely use a single relay in order to work a heavy load. So we'll go forward, and you can see that we will work a bit on these relay controlled systems. You can see that you need to know very clearly what are the relay symbols, because the same symbols will be used in programming the PLC. So unless you understand it properly, it will be very difficult for you to read the particular diagrams or programs that will be developing for a PLC. Now you can see what we have seen already, that when a current is switched on to flow through the relay solenoid, the normally closed contacts get opened and normally open contacts they get closed. Now these contacts are used to give control to the system. Now you can see that this is the NO contact, normally open contact, and this is the normally closed contact. Okay, so this is the symbol, you need to remember it throughout. Normally open, देखो दोनों के बीच कोई connection नहीं है, so this is normally open connection, and this is normally closed connection where the relay is getting the two terminals closed. Relay coil, the relay coil is denoted either by a full circle or by like your first brackets. Okay, now you can apply the relay for several operations. You can apply the relay to work on a contactor so that a motor can be connected to the contactor, because in case of three-phase motors you need to have a contactor, or for a hydraulic or pneumatic valve operation it can be given to a DCV, राइट एंड अभी में हम क्या करेंगे कि ये सिंबल्स हमको पता चल गया है, वी हैव कम टू नो अबाउट दिस सिंबल्स, एंड नाउ वी विल ट्राई टू रिप्रेजेंट अ सिचुएशन विद द हेल्प ऑफ अ वेरी सिंपल कंट्रोल ड्राइंग. ओके, लेट अस गो फॉर दैट. देखो यहाँ पे हम क्या करने की कोशिश करेंगे, यहाँ पे हम ये कोशिश करेंगे कि हम अपना रिले चालू करेंगे, और रिले चालू होने के साथ साथ जो सोलिनॉइड वाल्व है, जो सोलिनॉइड आपने देखा है, एक मे बी सोलिनॉइड वाल्व मैं आप लोगों को दिखा देता हूं आफ्टर दिस लेक्चर. द सोलिनॉइड वाल्व विल बी एक्टिवेटेड. सो रिमेंबर, दिस इज द रिले कॉइल, this is the relay coil, and this is the solenoid. Okay, this is a momentary push button switch, and this is the contacts of the relay. अभी आप अच्छे से समझ लीजिए कि ये जो आपकी रिले है, रिले की कॉइल इज डिनोटेड एज, ये जो रिले की कॉइल है दैट इज डिनोटेड थ्रू दिस फुल सर्कल और द फर्स्ट ब्रैकेट्स, एंड this normally closed contact is denoted by this, and your normally open contact is denoted like this. Okay, so this is the thing that you need to remember. When I am talking of such a circuit and I am talking that this is the relay contacts NO, then you need to understand this is the same relay, coil of the same relay and NO contact of the same relay that we are using in that circuit. Now this particular structure is the ladder structure that you will be using while you are programming a PLC. But please remember, ladder structures were not the structures which were developed for merely programming the PLCs. PLC आने के काफी पहले से ही ladder structure यूज किया जाता था in order to draw electrical diagrams. तो यहाँ पे ध्यान में रखिए, इसके कुछ रूल होते हैं. दो ये जो आप वर्टिकल लाइंस देख रहे हैं, दिस इज वर्टिकल लाइन 1 एंड दिस इज वर्टिकल लाइन 2. ये जो वर्टिकल लाइन है, दीज आर द पावर रेल्स. रेल बोलने का मतलब है जैसे कि अपनी रेलवे लाइन होता है ना, वहां पे दो ऐसे पटरी रहते हैं जिसको हम रेल की पटरी बोलते हैं. ओके, दीज आर द टू पैरेलल लाइंस विद इन विच देयर आर द स्लीपर्स. ओके, सो लाइकवाइज these vertical lines are the actual power lines. So this is where from the power gets into the circuit, and this is where from the power is completed, the circuit is completed. So you can think that this is your line and this is your neutral, this is your positive and this is your ground, like it. Okay, you need not to draw it or you need not to show it. This is the worldwide accepted structure for drawing electrical circuits. Anywhere you give this, they will be understanding, okay fine, this is the circuit. Now you see the horizontal lines to the systems are connected. ये जो है इसके बीच, ये आपके जो इलेक्ट्रिकल रेल्स हैं, इलेक्ट्रिकल लाइंस हैं, पावर रेल्स जिसे बोलते हैं, इसके बीच जो हॉरिजॉन्टल लाइंस रहते हैं उसमें हम सिस्टम को कनेक्ट करते हैं। अपने सिस्टम बोले तो क्या, ये रिले की सोलेनॉइड को हमने कनेक्ट किया, ये ऑन ऑफ स्विच को हमने कनेक्ट किया, दे आर कनेक्टेड इन बिटवीन देम। अभी आपको ध्यान में रखना पड़ेगा काम होता कैसे है, टोटल ये जो चीज है इसमें काम क्या होता है। ध्यान में रखिए, द सीक्वेंस ऑफ इवेंट्स इज रेड फ्रॉम टॉप हॉरिजॉन्टल लाइन टू डाउनवर्ड्स। ये समझना बहुत जरूरी है। इनिशियली whatever operation will be happening, that will be happening in the first line, then it will be happening in the second line, then it will be happening in the third line likewise। अच्छी तरह से आप देखेंगे तो आप मन में ये कंसेप्चुअलाइज कर सकते हैं that power will be flowing through this way, then it will come in this way, then it will come in this way, and accordingly it will move। यहाँ पे जो हॉरिजॉन्टल लाइंस हैं, ये जो हॉरिजॉन्टल लाइंस आपको दिख रहा है, ये हॉरिजॉन्टल लाइंस, these are called rungs, R-U-N-G, these are called rungs। Don't remember this please। So now you see in the top line, I am talking of this fourth line, in the top line when the on off switch is closed, मतलब मैं क्या बताने की कोशिश कर रहा हूं कि आपने ये ऑन ऑफ स्विच को क्लोज किया। अब आप लोगों ने मोमेंटरी पुश बटन पता है आप लोगों को, कैसे कैसे प्रकार की स्विच पता है आप लोगों को, हाउ मेनी टाइप्स ऑफ स्विच यू नो। ओके, एसपीडीटी, थ्रो स्विच, टॉगल स्विच, पुश बटन स्विच, एनी आइडिया अबाउट दिस, एनीबॉडी एल्स। अनुराग छोड़ के बाकी कोई कुछ बोल सकता है, एनी यू हैव आइडिया अबाउट डिफरेंट टाइप्स ऑफ स्विचेस। ओके, आई थिंक आई शुड swallow it। नॉर्मली हमारे घर में जो स्विच रहते हैं ना, दे आर आइदर क्लोज्ड और आइदर ओपन। मतलब क्या होता है कि आपने स्विच को एक तरफ धक्का मार दिया, दी टॉगल स्विच जो आप घर में लाइट या फैन ऑन करते हैं या ऑफ करते हैं, दे आर आइदर क्लोज्ड और आइदर ओपन। ठीक है, अभी आपके सामने देखिए ये एक स्विच मैं दिखा रहा हूं, व्हाट यू कैन सी हियर, एक प्रकार की स्विच है। आई विल नॉट टॉक इन डिटेल बट यू कैन सी ये उस स्विच की एक्चुएटर है। You can close it, once you leave it, it gets opened like this। Now it is opened again, you can see here। So such type of switches are called momentary push button switch। आपके घर में ऐसे प्रकार के स्विच कहां पे है, आपके कॉलिंग बेल पे है, जहां पे आपने छोड़ दिया वो स्विच आपकी फिर से अपनी पोजीशन पे चला जाएगी। सो दिस इज कॉल्ड, these such type of switches are called monostable switches। It has got only one stable condition, which is the condition which you can see right now। This is a normally open switch। This switch is normally open means you can see these are the two terminals, this is terminal 1 and this is terminal 2। okay, you can see here these two terminals are not connected to each other। When you press, this becomes momentarily connected, when you release this pressure, this becomes again disconnected। The idea is clear? Okay, now I will get back to again this thing। Now here I have connected a momentary push button switch, right? I have connected a momentary push button switch। Now when we are pressing the switch, your relay will get energized। When the relay is going to get energized, your normal open terminal will be getting connected। इसका मतलब क्या हुआ कि जब भी the moment you are pressing this switch, several things are happening, you can see। you have pressed this switch. When you have pressed this switch, current will pass through the relay solenoid coil. When the relay will be passing through the solenoid, your NO will become connected and your solenoid valve will come into action. So this is the thing that I wanted to make you understand. So when the solenoid valve is getting under operation, that is your solenoid valve is actuated, then maybe your drill will start or your motor will come down through the rail, what we have seen earlier. Now can anybody tell me what is the problem of this circuit? ये सर्किट में बेसिक प्रॉब्लम आपको क्या दिख रहा है, ये बताइए मुझे. एनीबॉडी ऑफ यू? आप लोग मुझे बता सकते हो? आई एम देयर इन द लाइन. देखो मैं मेरे लेक्चर में आप लोगों को कुछ भी नहीं पूछूंगा, सिर्फ मैं बताते रहूंगा, ऐसा नहीं चलेगा मुझे. सो ये जो सर्किट आपको दिखा, इस सर्किट में क्या प्रॉब्लम है आप मुझे बता सकते हो? यस मिस्टर सुमित, यू वांट टू टेल समथिंग? Anybody there who do feel that there is a problem in the circuit? You see, I seriously want this lecture to be bidirectional, because if you do not tell me anything, then I will not be in a condition to know whether you have got the topic or not, and I will have to leave my lecture. So therefore you need to talk. Is there anybody there? आप लोग कोई कौन कौन है यहाँ पे? कोई मुझे बता सकता है कि लेक्चर में कोई है भी या नहीं? आप हो? अच्छा, वेरी गुड. तो आपको बताना चाहिए ना. ये वो इंसान 40 साल का एक इंसान आपके सामने बार बार सवाल कर रहा है, आप कोई हो कि नहीं, हो कि नहीं, एंड यू डू नॉट हैव दिस ब्यूटीफुल सिविलाइज्ड मैनर टू टॉक. सर वी आर बिजी इन समथिंग. अभी आपको हम जवाब नहीं दे रहे हैं, हम खाना खा रहे हैं. अरे बाबा कुछ तो बोलो. I can see Mr. Nageshwar Ambolkar over there, Mr. Sumit Kirtikar over there, who are my students in my graduation. They do not have that much civilization that they need to answer when a teacher talks. It's very absconding. Anyway, there is no point in shouting at you. You can see that the basic problem that lies with this circuit is that when we release this switch, this circuit will get off again. So in order to make this circuit operated, you need to continuously push the switch, or you need to have an SPDT sort of switch here. So in order to get rid of this problem, this is the further development in the circuit. Now you can see, whatever you can see in front of you is basically a latch concept, the concept of a latch. Now what we have done, there is a start switch and there is a stop switch. The stop switch is always closed, under closed condition. When you put the pressure or you put your force on the switch, it will be getting disconnected. So I will show you this concept here. You can see this is a ladder diagram. Okay, this is a ladder diagram where you have got one NO switch and one NC switch, which is finally connected to a coil. So what I will do, I will run this system and see what is happening. You can see that this is the left rail and this is the right rail. The right rail is not shown in this particular, this is a Delta PLC software, but the right rail is not shown under normal, never. Okay, so now you can see this is a normally connected thing, normally connected coil, and this is a normally open coil. So you can see that the normally open coil is not connected right now, or we have not energized it right now, and therefore there is no connection to the coil. Now what I am going to do, I am going to set it on. So when I have put it on, you can see the coil has been energized. Okay, now what is the purpose of the push to on switch? You can see when I put this on, normally this is in normal condition. When I put it on, you can see this is off. So this thing you need to understand. Okay, this is one switch which is normally open, and this is one switch which is normally closed. When we press it, it goes open and opens the circuit. Now I put it off, you can see the motor is again in operation. So such type of things are there when you use normally in O switch and NC switch. Okay, now you see that whenever you have started the thing, you have pushed this on. Whenever you have pushed it on, what is going to happen? Let us see here. Your current will start passing through this relay, and when this current has passed, your electricity has energized this relay, then this NO will get connected. When this NO gets connected, then you can see current will pass through this path to the relay. So now you are free to release your start button. आपने start button छोड़ भी दिया तो भी आपका relay चालू रहेगा. And this is the second contact. This is the second contact of the relay. This relay is particularly a special type, or you have to use two SPDT relays in order to make this happen. This is one NO contact and this is the other NO contact. So when this relay is energized, then this relay comes into operation and your solenoid valve will be getting energized. ऐसे कंडीशन में अगर आपको सर्किट को ऑफ करना है तो क्या करना पड़ेगा? You need to push this switch. The moment you push this switch, यहाँ पे जो आपकी current flow हो रहा था, that current will be blocked at this point. So when your current will be blocked, your relay will be put off and your solenoid valve will be stopped. Now you have to remember that this is only part of the control drawing. This is only part of the control drawing, and your control drawing is much more larger according to the situation of the demand of the situation. So you need to remember that this is the basic operation of a relay controlled system, the basic latch operation I have shown to you, and now you have understood that when we are using a relay, we need to employ several wiring connections in order to happen a very simple work to be done. You need to connect one switch, one wire from this point to this point, from this point to this point. You need to put the contacts back into the circuit. So you have to do all these things. Okay, this is the most cumbersome type. So this is one assignment that is given to you, that you kindly explain the working of this particular diagram. Okay, I will be sharing the photo to you immediately, so that you can work on it as your homework. This you have to present to me in my next lecture, or you can send me in WhatsApp to my personal account.
Okay, sir. Okay, sir. Okay, sir.
Okay. Now you can see that this is the basic drawback of a conventional relay based control system. You can see that this is the control panel of a relay based system. These are all relays. You can see that these are very heavy duty relays of Allen Bradley. This is maybe a picture of quite old version control panel, where you can see the several relays that are working over here. All the relays are connected through the wires, and you can see how cumbersome the circuit is. Here again you can see another circuit where several relays are working together in order to make a certain process happen. So these things were earlier there. These things were earlier there when you had no processor or your programmable logic controllers. So now you can understand that in order to change a particular process में अगर थोड़ी change आपको करनी पड़ेगी, ऐसा कोई परिस्थिति का उद्भव हुआ तो आपको क्या करना पड़ेगा? यहाँ से एक वायर को खोलनी पड़ेगी, दूसरी जगह में लगाना पड़ेगा, and there is every chance of getting some mistake done. और दूसरी बात कि अगर यहाँ पे कोई प्रॉब्लम आता है तो आपको सारे रिलेस को टेस्ट करके, वायर को ट्रेस करके आपको उस प्रॉब्लम को ढूंढना पड़ता है. So this was earlier the situation. This was earlier the, हाँ जी बोलिए. हाँ, ये जो रिले की सर्किट है ये पहले यूज होता था. ऐसा नहीं कि अभी बिल्कुल बंद हो चुका है. बहुत सारी जगहों में अभी भी अगर बहुत छोटी सर्किट है, समझो आपको एक मोटर को ऑन करना है, ऑफ करना है विथ यूजिंग मे बी अ लैच सर्किट, तो उसके लिए आप डेफिनेटली एक कंट्रोलर नहीं लगाओगे. तो ऐसे में एक आधा रिले, दो रिले से सर्किट अभी भी बनता है. बट नाउ ए डेज व्हेन यू हैव टू कंट्रोल अ वेरी मैसिव प्रोसेस, अब ऐसे टाइप के सर्किट और बाबा कहीं पे नहीं है. ठीक है, तो अभी क्या है, नाउ लेट अस सी व्हाट आर माइक्रोप्रोसेसर बेस्ड कंट्रोल सिस्टम्स. माइक्रोप्रोसेसर बेस्ड कंट्रोल सिस्टम में डेफिनेटली देयर इज अ वेरी इंटेलिजेंट लॉजिक एलिमेंट. देयर इज अ वेरी इंटेलिजेंट लॉजिक एलिमेंट कॉल्ड ए प्रोसेसर और ए कंट्रोलर. नाउ यू कैन सी that in a controller based system, instead of hardwiring each control circuit for each control situation, हर एक कंट्रोल सिचुएशन के लिए आपको अलग अलग सर्किट हार्डवेयर करने की जरूरत नहीं पड़ेगी. You can use the same basic system for all situations if you use a microprocessor based system, and you can run a very simple program to instruct the microprocessor that how to react to each input signal. कोई भी इनपुट सिग्नल अगर मिलता है आपको, तो उस इनपुट सिग्नल को देखते हुए आप कैसे रिएक्ट करेंगे, मतलब आपकी सिस्टम कैसे रिएक्ट करेगा, ये करना माइक्रोप्रोसेसर बेस्ड सिस्टम की काम है. और जिसकी वजह से क्या हुआ, ये हार्डवेयर रिले की जो कंसेप्ट थी, दैट कंसेप्ट हैज बीन मिनिमाइज्ड टू ए लॉट एक्सटेंट एट दिस पॉइंट ऑफ टाइम. नाउ अभी देखो, मैंने ये जो ग्रीन कलर की ब्लॉक है, यहाँ पे आपको दिख रहा है कि you have a system where there are certain number of switches. All these switches or sensors are working as inputs, and you have certain number of motors or valves as output. अभी प्रोग्राम में जस्ट एक एग्जांपल दिखा रहा हूँ. इफ स्विच ए क्लोजेस, अगर स्विच ए क्लोज होता है तो मोटर चालू हो जाना चाहिए. स्विच बी क्लोज होता है तो वाल्व चालू हो जाना चाहिए. तो ये चीज समझने के लिए पहले आपको स्विच ए के लिए एक रिले बनानी पड़ेगी, उस रिले की लैचिंग कनेक्शन बनाना पड़ेगा, उस कनेक्शन को बाद में देना पड़ेगा दूसरी एक मोटर सर्किट को, मोटर सर्किट के लिए आपको फिर से एक कॉन्टेक्टर लगानी पड़ेगी, उसको में भी लैच करना पड़ेगा. सेम विद स्विच भी. तो यहाँ पे आप देखिए कितना वायर्स पहले लग सकता था, बट अभी इतनी झमेला है नहीं. आपको वायरिंग सिर्फ प्रोग्राम में करना पड़ता है. ओके, नाउ यू सी दैट इन केस we are using a microprocessor based control system, what is the biggest advantage? We can simply change the instructions in the program, simply change the instruction, and we can use the same microprocessor system to control a variety of gamut of situations. Situations कुछ भी हो, if you have understood the situation and you can vary the program according to the necessity of the situation, then it will be very easy for you to employ the microprocessor to handle any sort of challenge in the entire control process. What I have given here is the example of a domestic washing machine. ये washing machine आजकल हमारे सबके घर में है. इसमें एक प्रोसेसर रहता है. आप लोग बोलोगे सर ये हम लोग वहाँ पे पीएलसी क्यों नहीं लगाते हैं, क्योंकि देखो बाबा आजकल एक माइक्रो प्रोसेसर ही आता है मे बी 12-13 हज़ार में, और वहाँ पे अगर पीएलसी का ही कीमत, मिनिमम पीएलसी का कीमत आप लेने जाओगे तो 5-6 हज़ार के नीचे तो पीएलसी मिलेगा नहीं. क्या मतलब है? So therefore there are actually dedicated controllers और processors. maybe एक Arduino से भी आपका माइक्रो प्रोसेसर के या अपना वॉशिंग मशीन का हर काम हो सकता है. तो why to use a PLC there? तो इसका मतलब नहीं कि हर एप्लीकेशन के लिए आप PLC इस्तेमाल करते बैठो, but there is a dedicated control unit, dedicated logic controller or a processor in order to collaborate every operation of the washing machine. You can see here, ये जो वॉशिंग मशीन आपको दिख रहा है इसके अंदर एक माइक्रो प्रोसेसर कंट्रोल सिस्टम बिठा हुआ है कहीं तो भी. दैट इज नॉन ऑफ आवर बिजनेस. लेट अस ट्राई टू सी व्हाट इज देयर इन द वॉशिंग मशीन. क्या क्या रहता है? देखो वॉशिंग मशीन में एक ड्रम रहता है, जो ड्रम घूमता है. ओके, दैट इज द वॉशिंग साइकिल. तो यू कंट्रोल द ड्रम मोटर. उस मोटर को आप कंट्रोल करते हो, मोटर को ऑन करते हो, ऑफ करते हो. यू कंट्रोल द स्पीड ऑफ द मोटर, स्पिन साइकिल. आप याद करो, ज्यादा जोर से घुमाते हो, धीरे जोर से घुमाते हो, दैट इज यू कैन कंट्रोल, इट इज योर हैंड. You can open or close the hot or cold water valves. You can control the drain pump. You can control the water heater, and there is a safety interlock. The safety interlock in the sense that if your door is opened, the motor will not start, and the motor will only start if your door is closed. इंडस्ट्री में ऐसा जो सेफ्टी रहता है, एक स्विच जब चालू रहेगा तो दूसरा स्विच चालू नहीं होना चाहिए. इस पर्टिकुलर जो कंसेप्ट होता है इसको बोला जाता है इंटरलॉकिंग कंसेप्ट. एंड कोई भी डिवाइसेस पे जब डोर ऐसा रहता है कि डोर खोलने के बाद आपकी हानि होने की चांसेस है, ये कंडीशन को हम हमेशा सेफ्टी इंटरलॉक दे के रखते हैं. Now you see that all these things what you can see over here, the control of dump motor or the motor speed, hot water cold water valve, whatever it is there, they are the output controls. They are the output controls. And what are the input controls in order to control these things? You have dials to select the required wash cycle. Required wash cycle means ये आप देखोगे कि आपकी जो वॉश साइकिल है उसमें मोटर पहले धीरे घूमेगा थोड़ी देर तक, उसके बाद फास्ट घूमेगा, उसके बाद फिर से धीमा हो जाएगा, उसमें 5 मिनट बाद कोल्ड वाटर गिरेगा, 2 मिनट बाद हॉट वाटर आएगा. ये सारे जो चीजें हैं ये आपकी एक एक वॉश साइकिल में ऑलरेडी प्री प्रोग्राम किया हुआ है. यू हैव ए डायल टू चूज द वॉश साइकिल. नाउ यू नीड टू हैव ए स्विच inside the structure of the machine to see whether the door is closed or not. You need a temperature sensor to determine what is the particular temperature of the water, because if the temperature sensor is damaged somehow, then the water will get heated up to n limit. Then you need to have a switch to detect the level of the water. So you need to have several sensors and switches at the input side, and according to the conditions of the switches, you see that if the switch or the sensor that detects the level of water, उस सेंसर को पता चल गया कि जितना वाटर हमें चाहिए उतना वाटर आ गया है, तो वो क्या करेगा, अपनी जो हॉट या कोल्ड वाटर की जो वाल्व थी उस वाल्व को क्लोज कर देगा. समझो आपने गर्म पानी चाहते हो, यू हैव डिसाइडेड कि मुझे गर्म पानी चाहिए अप टू 30 डिग्री सेंटीग्रेड या 45 डिग्री सेंटीग्रेड. यू हैव प्रोग्राम्ड इट. प्रोग्राम करने के बाद वाटर हीटर चालू हो गया. वाटर हीटर कब तक चालू रहेगा, जब तक ये टेम्परेचर सेंसर सेंस नहीं करेगा कि टेम्परेचर 45 डिग्री तक रीच हो चुका है. सो नाउ यू कैन सी that conditions of the input will determine the action of the output. And what you are needed to do, you are simply sitting at the user side and just putting some buttons together in order to determine what is going to be the output operation. यहाँ पे आपको रिले का बटन चेंज करने की, वायर चेंज करने का, एक टर्मिनल खोल के दूसरे टर्मिनल में लगाने का, ये सारी झमेला आपका पास नहीं है. This is the basic advantage of a microprocessor based control system. So this is where my first lecture conclude, and what I will do, I will just start with the second lecture and I will stop. Now you can see what is a programmable logic controller. A programmable logic controller is a special form of microprocessor based controller. इसका मतलब एक बात तो तय है कि प्रोग्रामेबल लॉजिक कंट्रोलर के अंदर एक माइक्रो प्रोसेसर बेस्ड कंट्रोलर बिठाया हुआ है. अब माइक्रो प्रोसेसर बोलने के बाद जाहिर सी बात है कि उसमें एक मेमोरी है. ये मेमोरी में आप इंस्ट्रक्शन पहले से स्टोर करके रख सकते हो, और आपको जैसे फंक्शन चाहिए वैसे फंक्शन लॉजिक के थ्रू, सीक्वेंसिंग के थ्रू, टाइमिंग के थ्रू, काउंटिंग के थ्रू और छोटे छोटे अरिथमेटिक फंक्शन के थ्रू आप डिफरेंट मशीन या प्रोसेस इसको आप कंट्रोल करने के लिए employ कर सकते हो. So here you can see the block diagram of a PLC. You simply feed it the program into it, and there are some inputs as well as outputs. When some condition of the input will change, then according to your program the output condition will change. The PLC is capable of handling logic functions, it is capable of handling sequencing functions, it is capable of handling timing functions, it can count or it can perform simple arithmetic. So with this much introduction to programmable logic controllers, I conclude my lecture right now. Now I am not going to talk and this session is open. If I do not find any question from your side for 5 minutes, I will be closing the session. Thank you. If you have got any question, you are free to ask. असाइनमेंट आप लोगों को व्हाट्सएप पे पहुंच गया? ओके फाइन. वो असाइनमेंट में क्या दिया हुआ है आपको, यू सी this assignment is having a certain control diagram, a relay, I can say ladder diagram. Okay, this ladder diagram defines a process. एक certain process इस ladder diagram के थ्रू डिफाइन किया जा रहा है. अभी आपको बोलना पड़ेगा वो प्रोसेस क्या है और ये रिले कंट्रोल सिस्टम कैसे काम कर रहा है. दैट्स इट. Okay, you can write down in a piece of paper and get a snap and give it to me. मैं ये सजेस्ट करूंगा कि आप लोग क्या कीजिए, ये सब्जेक्ट के लिए आप एक रजिस्टर बना लीजिए and whenever I will be talking about some of the assignments you can do it there. मैं कभी भी आप लोगों को कन्वेंशनल जो असाइनमेंट होता है देख देख के पृष्ठा भर्ती करो, ये मैं आप लोगों को कभी भी नहीं बोलूंगा. बिलीव ऑन मी, मुझे ऐसे असाइनमेंट पसंद ही नहीं है. मैं आप लोगों को कुछ टास्क दूंगा विच आई फील दैट दे आर ए बिट चैलेंजिंग, और आप भी ऐसे दिमाग में आपके कुछ आता है यू कैन जॉट इट ऑन योर नोटबुक. एंड मैं ये सजेस्ट करूंगा कि ये जो नोटबुक आप लोगे दैट शुड बी व्हाइट पेज नोटबुक, because there you will be finding it very comfortable to draw bigger ladder diagrams and you will be able to write your comments and something on that white papers. Okay. Okay, now in my next lecture I will be talking on this PLC architecture and hardware. Okay, so there I will have to get you introduced to the concept of sourcing and syncing and how the several input things and output things they are connected to a PLC. तो मैं ये आप लोगों से उम्मीद करूंगा कि आप लोग में भी, आज बुधवार है ना, तो शुक्रवार या शनिवार मतलब आइदर ऑन फ्राइडे और सैटरडे इफ यू कैन कम डाउन टू दीनदयाल उपाध्याय कौशल केंद्र, आई विल एक्चुअली शो यू दैट हाउ द थिंग्स आर गेटिंग कनेक्टेड टू द पीएलसी एंड व्हाट इज द कंसेप्ट ऑफ सोर्सिंग एंड व्हाट इज द concept of syncing. So if you see the things once, then it will be very easy for you to understand the whole process. Okay, so if I am to talk a lot about that sourcing and syncing, once you see the thing there will be no necessity of doing this giggleness anymore. तो आप लोग शुक्रवार या शनिवार मे बी यू कैन मेक इट ऑन सैटरडे, यू प्लीज कम डाउन टू ए पर्टिकुलर टाइम. आप लोग मुझे वो टाइम बता दीजिए, आई विल अरेंज सम एक्सपेरिमेंट्स एंड आई विल शो इट टू यू. ठीक है. Okay, so if you have got any more question please let me know, or otherwise I will conclude the session. You have a lecture from 12 itself ना, आप लोगों का 12 बजे भी एक लेक्चर था ना. हाँ, as per the timetable you have a lecture. I don't know, there is no link for the lecture. Okay, fine. So can I take your permission to leave the lecture? Thank you.
ते कोणत्या फर्स्ट इयर सेकंड इयर कोणत्या वगैरे ते
मास्टर्स के लोग, मास्टर फर्स्ट ईयर.
ह्याचे पुस्तक मिळत असेल की हो, बुक मिळत असेल की ह्याची?
कौन सी, किसकी?
फर्स्ट ईयर की बुक मिलते होंगे?
नहीं, ये कोई फर्स्ट ईयर मतलब ग्रेजुएशन में कैसा है ना सर कि ग्रेजुएशन के कोर्स की बुक नहीं मिलता.
अच्छा.
यहाँ पे आपको अलग अलग बुक से पढ़नी पड़ती है. एंड आई हैव ऑलरेडी शेयर द बुक्स विद द स्टूडेंट्स. मैंने ऑलरेडी शेयर कर चुका हूँ. मैंने कल कुछ बच्चे आए थे, आप क्या कीजिए बच्ची का आई कार्ड बना लीजिए, और आई कार्ड बनाने के बाद यू कैन हैव द बुक्स फ्रॉम आवर लाइब्रेरी और सेंट्रल लाइब्रेरी.
आई कार्ड कुछ बनवाइए.
आई कार्ड आपको क्या करना पड़ेगा, आप मेन बिल्डिंग में जाएंगे जहाँ से आपने फीस पे किए थे, उसके बाजू में एक खिड़की है, वो खिड़की में आपको ये मिलेगा, क्या बोलता है उसे, पब्लिकेशन यूनिट है. वो खिड़की में बोलिए आई कार्ड देने के लिए आपको, तो 5 रुपये कुछ रहता है. आई कार्ड आपको लेना पड़ेगा, फोटो लगानी पड़ेगी, ऑफिस में जमा करना पड़ेगा. तो ऑफिस में डायरेक्टर सर साइन करके और आई कार्ड आपके बच्चे के हाथ में आ गया,
बना देते.
तो फिर उसमें आपको फिर आप जो मेन बिल्डिंग है, मेन बिल्डिंग के पीछे सेंट्रल लाइब्रेरी है, सेंट्रल लाइब्रेरी में जाके आप बुक ले सकते हो, या अपने डिपार्टमेंट के लाइब्रेरी में से भी आप बुक ले सकते हो. सेंट्रल लाइब्रेरी के बुक में कहीं पे भी, मतलब डिपार्टमेंट की हो कि सेंट्रल लाइब्रेरी की हो, आपको 7 दिन के अंदर बुक वापस करनी पड़ती है, अदरवाइज वो फाइन बैठता है. हमारे पास हम फाइन नहीं लेते, बट हम बोलते बच्चों को कि 3 दिन के बाद दे दो, क्योंकि बुक्स कम है ना, डिपार्टमेंटल लाइब्रेरी में बुक्स कम रहते हैं, सब बच्चे पढ़ पाए. बट ये बुक्स का खरीदना इतने पॉसिबल नहीं कि एक बुक की कीमत 1000 रुपये 1500 रुपये बुक है, तो उसको खरीदने का कोई मतलब ही नहीं है. हम आप लोगों को दे ही देंगे. मैंने बच्चों को कल बताया कि आप लोग पेन ड्राइव लाओ, मेरे पास सारे बुक्स की सॉफ्ट कॉपी है, मैंने डाउनलोड करके ऑलरेडी मैं खरीद के रखा हूँ.
कितना जीबी का पेन ड्राइव लगेगा?
मैं दिया हूँ ना अश्विन को.
दिया है.
अश्विनी लेके गई पहले, उसको मैं पहले ही बता दिया हूँ कौन सी बुक से क्या करना है। फिर भी बच्चे को कोई प्रॉब्लम हो ना तो मुझे बताने को बोलो, मैं बोल देता
प्रॉब्लम कोई नहीं, कोई लड़की लड़की लोग आ रहे नहीं ना उधर, इसलिए बोल रहे थे कोई आ रहे नहीं, आज भी कोई आया नहीं, अकेले बैठी हो।
हूँ। कोई प्रॉब्लम, लेडी लोग है ना पढ़ाने के लिए, तो आप उतना सोचिए मत, कुछ नहीं होगा। और 3 घंटे रहेगी। उसको गाड़ी चलाना नहीं आता क्या अभी?
आता नहीं।
आता है। आप लोग रहते कहाँ पे हो? पड़ेगा
पड़ेगा।
पड़ेगा। हाँ, बीच में
5-6
इतना
किलोमीटर।
थोड़ी एरिया है, बट ये नंदनवन के अंदर से गए तो कोई टेंशन नहीं।
टेंशन नहीं।
हाँ, मैं तो पड़ेगा वहीं से जाता हूँ। मैं संडे को ये में जाता हूँ, थोड़ा वो राइट रोड पे जाके वहाँ पे मैं कोई ना कोई ढाबे पे मैं ब्रेकफास्ट करता हूँ, ये मेरी आदत है।
अच्छा।
हर रोज घर का खाना अच्छा नहीं लगता मुझे। और ये 2001 से 2000 समझो 14 में मेरा शादी हुआ, तो 2001 से 2014 ये बाहर का खाना खाया ना, मुझे हर रोज घर का खाना ना मुझे वो कैसा तो भी लगता। कल एक बच्चे ने किसी ने दिया।
बंडेवाड सगळे भेटत नाही. हा?
अभी मैं हेमा को फोन लगाता हूँ, क्या पूछ रही थी?
चलो सर, मैं आता हूँ.
आ जाओ सर। वहां से
बंडेवाड सर कहाँ है, मिले नहीं अभी तक.
बंदेवाड़ बंदेवाड़ सर तो अंदर में बैठते हैं। वो जो क्लासरूम है ना,
हाँ.
वो क्लासरूम के बाजू का जो रूम है, मैं आइए आइए मैं दिखाता हूँ। यहाँ से दिखा देता हूँ।
मिले नहीं, वो मिलके चलता हूँ.
हाँ,
गाँव के है नजदीक के.
अच्छा सेम नजदीक के गाँव है।
हाँ.